Better. Uh, what we want to know is what makes something a circle. How do we define it? How do we? If I were to tell you, if I were to tell you draw a circle, if I'm trying to tell a computer or tell someone who's never seen a circle before to draw a circle, what are instructions that I could give to kind of pick these points that I'm choosing? Each of these is a little point. How could I give instructions, a way to find every single point on this circle? How do I know if a point is supposed to be on the circle or not? So that's our first question, because if we can do that, then we can get a definition. Now, the answer to that relies on the way that we drew a circle near the start of the year. I had you guys use what's called a compass. And what we did, and it's going to be hard to do with the technology I have right now. What we did was we picked one point, one kind of pivot point, and then used that to extend out a length and then trace that length around that one focus point. And this was the end with the actual pencil that you used to trace around. And then the other end just had this kind of sharp end to keep the focal point. So this focal point that we base everything around is called the center of the circle. So we have a center, and then the other thing that we did was we fixed out a specific distance. Right? We extended it out, and it could be this distance, and the distance was smaller each time. And the way that we traced it around, it guaranteed that the distance stayed the same no matter where we were in the circle. This distance is the same as this distance, is the same as this distance. Hypothetically, of course, this isn't a perfect circle. But any of these distances, if I took the center and a point on the circle, then the distance would stay the same no matter what. And that distance should be familiar to. It's what we called the radius. Radius. All right, so those are the two components that make up the circle. We need a center, which is a kind of focal point to start from. And a radius, which is our distance. And if you know that, the center and the radius, then you know what circle we need. You can have circles with the same radius and a different center. So we could take this circle. If I took the circle and shifted it down here, it would be the same radius, but it would have a different center. It would be centered over here instead. I could draw another circle inside of here, and I could have it have the same center but be a different radius, like that. So this would have the same center, but the radius would be different. So those are the two things that you can change about a circle. You can change its center, or you can change its radius. And those are the two building blocks. The center, that focal point, and the radius, that distance, is the components that make up a circle. And so our definition of circle that we're about to write uses those two building blocks. And the important thing here is that the two terms that I just talked about are buried in here. The fixed distance is my radius. And that focal point is what we call the center. In fact, a lot of definitions of circle that you see are going to use the word center there. The set of all points in equal distance from the center. And that's the way we build a circle. We pick a center to start from, and then we pick a distance we want all the points to be, and we trace it around, and that's our circle. So, how do we build a circle? And I want to start, before I answer that question, let's review a different question, which is, well, let's talk about how we build a line. Didn't mean to put that in caps lock. There we go. Let's talk about how we build a line first, and then we'll talk about how we build a circle. So if we have a line, here, okay, what are our instructions that we usually use to make that line? Well, usually what we do is we have a, let's make a little XY graph here. Right, not going to make anything too fancy here. Let's make a little XY graph. And what we usually choose to use is a point. We use a point to start with. Okay, and then we basically tell it from that point, what direction do you want me to go? Okay, we point it in a direction. We say, go this way. And then, go the same way in the opposite direction. And the way we give it that direction, well, first of all, the point that we choose, when we do y equals mx plus b, this is what we're basing it on, y equals mx plus b. This b is our starting point. So that starting point is our y-intercept. And then the direction, the way we give the instructions for the direction is to say, you know what, every time we go to the right one, I want you to go up 3. Or every time we go to the right one, I want you to go down 2. Every time we go to the right one, I want you to go up this or down this amount. So that is our slope. And that's how we build a line with these two pieces. Now, the way we want to build a circle, so instead of picking a point and a direction, we are going to pick a point to start from and a distance. We're going to pick a point and we're going to pick a distance because we want to keep that distance the same. That's what makes it a circle. So that point, if I can write in my pen here, that point is going to be my center. And then my distance will be the radius. How about an A? There we go. All right, so how do we guarantee a distance? How do we guarantee a distance? Well, we've got a formula for that. Okay, and if this feels complicated, don't worry. We're gonna break it down into more manageable pieces in just a second. But I want to show you that this is just a background to show you that this comes from somewhere. So when we fix a distance, well, we've got a formula for distance. All right, so distance equals, well, here's the formula that we had for distance. And we talked about how this came from the Pythagorean theorem, and we've used this formula all the time throughout the year. So hopefully it at least looks familiar to you. I just want to remind you that it exists. That we have a formula that we can use to build a distance on a graph. Okay, and so all we need to do is that we want this distance to be our radius. And we want it to stay the same. And then we want it to be the same distance from the center. So we want to build a way that will keep this distance the same, and will keep the center the same as well. All right, so for radius, I'm going to use r. And I want r to be the same regardless of what point I plug in here. I want to control this distance, and so I'm going to keep it the same. R equals square root. And then I'm going to the other thing I want to control is my center. And where do I want my center to be? Again, I'll give you a moment to ponder that. Where's the center going to go in this formula? Think about what we would do for the center. Well, we would put it as a point on the graph. And so we want it to be a point. We want it to be one of the points. So we want to use the center for these points. And just as a convention, once you get to algebra 2, you might be able to make a connection as to why this is. But what we use is, for center, is, so we have x minus our center coordinate squared plus y minus our other center coordinate squared. We use, for the x coordinate of the center, we use h. And for the y coordinate of the center, we use k. And our radius, we're using r. And these are all going to end up being numbers instead of variables. These are things we're going to plug in for numbers and figure out each time we build our equations. All right? And the only difference in the formula is that I don't like the square root. That makes it messy. So what I'm just going to do is I'm going to square this whole equation. Squared, and we're going to square this side. And if I take because the nice thing is, if I take a square root and square it, then they just cancel, and I just have x minus h squared plus y minus k squared. And so what we're building is that we're just keeping this distance the same every time. This number stays the same, and we're keeping one of the points the same. And so anything that makes this equal will guarantee that my distance from this point to the center that I choose will always be that radius. So we'll write the center and radius every time, because remember, those are our building blocks of the circle. We need a distance that stays the same, and we need a center to focus our circle around. All right? So here we go. So first off, we're going to start by writing an equation from the graph. So we're gonna read what the circle looks like and then build an equation from there. And then we'll go the other way. I'll give you an equation and you're gonna make the graph. Here we go. Center and radius. All right, our center is our focal point where we're building our circle around, and our center is right here. It is at the origin. It's at 0, 0. All right, so that's actually going to make this equation a lot easier because things get simpler when it's 0. Radius. Radius, remember, is our distance. Is our distance that we fix. So here's a radius. Or you can just build it out to the right, or anything that you can just count the distance easily. 1, 2, 3, 4. So our radius here is 4. All right, and so these are the numbers that's going to go into this general structure. Just like for y equals mx plus b, we put our slope in for m and our y-intercept in for b. So now, our overall structure is going to generally look like x minus, leave a space there, squared, plus y minus, leave a space, squared, equals something squared. And remember, this comes from the building block of the distance formula. We're keeping that distance the same. So that's why we're using the distance formula. X minus, our x-coordinate of the center is 0. And hopefully you should be able to keep track of it. The x-coordinate goes with x, the y-coordinate goes with y. And then our radius is 4. So 4 goes here. Well, that means that it's going to get a lot simpler because x minus 0 is just x squared. Plus y minus 0, that's just y squared. Equals 4 squared, that's 4 times 4 is 16. So here's our final answer. X squared plus y squared equals 16. That's the equation of this circle. So any point that's on this circle, this point, this point, this point, if I get its x and y coordinates and I put it into this equation, this left side is going to come out to be 16 every time. That's the idea behind building an equation like this. So that if I plug in a point for x and a point for y, it's going to be on that circle. And if I plug in a point for x and a point for y and it doesn't work out, then it's not on the circle. So like if I pick 1, 1, then 1 plus 1 is 2. That's not 16. It's not on the circle. Okay. Let's do another example here. And I want you to start it. So I'm going to give you a moment to start it. Let me write the form again. So that you have that to refer back to. And the way I want you to start this is by determining what our 2 building blocks are. Remember, our 2 building blocks are the center and the radius. Center's right here. So that's at -1 for the x-coordinate and up to 1, 2, 3 for the y-coordinate. -1, 3. And then our radius is our distance that we're fixing. And so our distance out from the center is 1, 2. And we hit a point on the circle. So our radius here is 2. So then when we go to write our equation, squared. Our x-coordinate of the center is -1. Well, let's write that again. X-coordinate of the center is -1. And then our y-coordinate of the center is +3. So that goes over there. And then our radius that we want to fix is 2. So to simplify that a little bit, we have x minus a -1. That's going to turn it into a positive. Plus y minus 3 squared equals 2 squared is 4. So there's my final answer. X plus 1 quantity squared plus y minus 3 quantity squared equals 4. And that's our equation of that circle. Again, what we'll do in a minute is we'll start with this and go to the graph. That's where we're headed. The center, here it is. Center is here at 1, negative 1. 1, negative 1. So our x and y coordinate in the center. And then our radius, is our distance. Distance out here. Okay, and so we count that. That's 1, 2, 3, 4, 5. So our radius in this case is 5. So now we make our outline of our equation. And the reason I'm writing this part in black is because it stays the same every time. This part is not going to change. Plus y minus, and then I'm going to leave a space, squared equals, and then our radius squared. This does not change. This structure stays the same. So we're going to use our center. Our center is at 1, negative 1. So 1 goes here, negative 1 goes here. And then our radius is 5, so 5 goes here. And now to simplify that, x minus 1 squared plus a y minus a negative 1 is going to become y plus 1 squared equals 5 squared is 5 times 5 is 25. Now, one more thing to notice here before I go on. One more thing to notice is that, well, actually 2 things to notice. 2 things. Let me write them down. 2 things. Because they're going to be important here in just a second. First thing. 2 observations of patterns here. First off is that the center switches signs. In the equation. And the reason that happens, well, first let me say what I mean by that. Whoa. There. What I mean by that is that you'll notice how the center, the x-coordinate was at 1 and the y-coordinate was at negative 1. But then when it went into the equation, the x-coordinate was subtracted. And then the y-coordinate, which was at negative 1, is now added. They switched. Now, why did that happen? Why do we have a plus here when it was a negative 1? Well, it's because the formula that we're working from has a minus sign in it. So we're actually looking at what's getting subtracted. What's getting subtracted is a positive 1. So if you see x minus 1 over here, you'll know that that x-coordinate should be a 1, because that's what's getting subtracted. And then over here, to y plus 1, to build that, we had to subtract a negative 1 to get there. So if you see a y plus 1, that means that the y-coordinate that it came from was negative 1. And the second thing I want you to notice is for the radius. R is squared. Okay, and the reason I say that is because, again, we're going to go from this equation to a graph. And when we do that, I don't want you to think that 25 is the radius. This is r squared. This is r squared. So you're going to have to work backwards and make the square root of it to actually figure out what the radius is. When you see 25 here, you should be taking the square root of it and working backwards to say, oh, the radius had to have been 5 in order for this number to get to 25. So the center switches signs because we're looking at what's getting subtracted, and the radius is squared in this piece of the formula. All right, so keep that in mind, because now we're going to look at going to the graph. Because some of these I'm going to kind of give you the center and radius, or work from a place where you can get the center and radius, and then some of these problems we're going to build the circle from the center and radius, or from the equation. So we're gonna do this in the opposite direction now. Now we're gonna go from here to what's the center and radius to make the graph. Here we go. Here we go, here we go. First example. The equation is x minus 3 plus squared plus y minus 2 squared equals 16. Let's start with the center. The center is in these places right here. And remember that the signs are switched. So we want to think about, another way you can say that is you can think about what got subtracted. What is being subtracted here? Well, I'm subtracting 3. So 3 is the x-coordinate. And what am I subtracting? I'm subtracting 2. Or, like I said, the signs are switched. So if you see a minus 3, then there should be a positive 3 here. If you see a minus 2, there should be a positive 2 here. So my center's at 3, 2. Let me go ahead and put that on the graph. 1, 2, 3, up to 2. There's my center. And then my radius is my distance. My radius comes from here. But remember, r is squared. So if I used 16 here, well, r is squared. So instead of 16, I want to take the square root of that. So I want the square root of 16, which is 4. So my radius is actually 4. And so the way I'm going to build the circle, just as a kind of, since I don't have a compass, the way I'm going to build this circle is that I'm going to go up, down, left, right to get 4 points that are definitely on the circle. If I go 4 to the right, and then I go up 4, that's another point. If I go to the left 4, that's another point. And then if I go down 4, that's another point. Okay, here we go. Let's see how this turns out. Not terrible. Not terrible. In class on my smartboard, I have a nice circle tool that I can just click a button and it'll make a circle. But now I gotta draw it. So that's how we can build the circle. Get your center. Pick up, down, left, right, your distance, your radius, and then draw your circle that way. Let's go another one. One second. I want to make a different number than 16. 64, 9. So let's do, instead of 16, so this is going to be a different circle than I have here. Instead of 16, I'm going to make this... 36. So it's going to be x plus 2 squared. So let me rewrite the equation. X plus 2 quantity squared plus y squared. What does that mean? All right, so now that my number here is 36, remember this is r squared. This is r squared. So when I do my radius, I want the square root of that. Square root of 36, which is 6. Now the center is tricky. So I'm going to actually give you a second to think about what the center of this circle would be. Remember, the question you should be asking yourself is what is subtracted to create this? X-coordinate, what's getting subtracted here? Hopefully most of you were able to get the x-coordinate. X minus, well, what's subtracted is negative 2. Negative 2 is getting subtracted because in order to build the plus 2, I would have had to have come from x minus negative 2. And that negative 2 is my coordinate of the center. And then over here for y, what's getting subtracted? What's used to build that? Well, nothing. Nothing is getting subtracted. So that must mean that it's 0. Because remember that we did that in the very first one we did, we had a y minus 0 squared. And then we said, oh, hold on. Wait a second. The pen's writing all over the place. That's what we said. No, we said, hold on a second. Y minus 0 is just y. So why don't we just write y squared and be done? So that's what's happening here. What's being subtracted is 0. So negative 2, 0 is my center. Boom. And then we're going to go 6. Remember, the way I'm doing this is I'm going 6 to the right, 6 up, 6 down, 6 left. Even better if you got a compass and can just go 6 to the right and then just trace a circle around. Doesn't have to be perfect. Here's 6 to the right. Here's up 6. Some parts better than others. All right. So now we're working backwards here. I'm giving you the equation, and from that equation, we're figuring out what the center and the radius had to be, and then we're just putting that on the graph. Put in our center, use the radius as our distance. 2 more. The center goes in this spot. Here and here. That's where we find the center. So H and K just give you a placeholder of here's where you can find the center. Here's those places. That's all it is. And we pick H and K because why not? Oh, there's our center. 1 and 2. Remember, the signs get switched. So we're subtracting positive 1, we're subtracting a positive 2. Subtracting 1, so 1 is our x-coordinate. We're subtracting 2, so 2 is our y-coordinate. 1, 2, there's our center. And then our radius is 64. That's ridiculous. Oh, of course it's not 64. It's the square root of 64. Because remember, this is r squared So 64. Square root of 64 is 8. And why is it squared? It's I just want to go back and remind us about why it's squared. Like, why did they choose to square it? Why not just keep it r? Well, because it came from the distance formula that had this big fancy square root inside of it that we didn't like. And so we just squared the whole thing and said, why not get rid of the square root and just make this r squared? That makes it a whole lot easier to work with because you're not dealing with a bunch of square roots. The downside is that you got to think about this r squared thing. Square root of 64, which is 8. There we go. So now I'm going to work with 8. Up 8 would be here. Speed draw. Oof. That might actually be one of my better ones, is the sad thing. Now, how did we get that? Well, our center, we got to look at what's subtracted, so we got to switch our signs. This is not 1, 1, it's negative 1, negative 1. Right? If I got a plus there, it had to be negative to start with. We'd have to subtract a negative 1. Then our radius is not 9, it's the square root of 9. Because r is squared. So our centers should be at negative 1, right there. And then our radius should be 3. And then draw your circle around. But draw a better circle than I drew. And I'm not too picky on the drawing. As long as I know that it's not like a square, then you should be fine. Just make sure you're clear that it's a circle and it doesn't have a corner to it. All right, so that's it for me for now. As always, take care of yourselves. Thanks so much for coming and sticking with me. We just have a couple more weeks left, so hang in there and keep at it. And I will talk to you more soon.